Hello and thank you all for joining us today for this educational Innovyze webinar. My name is Caitlin Nyan and I'm part of the marketing team here in the Innovyze Portland office. In this webinar, we'll discuss the role of hydraulic model results can play in effective decision making and how it's becoming more and more prevalent as systems become increasingly integrated. For those of you who may not be familiar with Innovyze, we have a long history of providing high-performing, innovative software solutions. Our intention is to make sure that in your work, you can design, model, review, and manage with confidence. This also means that we strive to provide excellent customer service and support, and that we offer continuing education opportunities like these for engineers and others in the industry. Innovyze offers a library of software programs to design, analysis, and management of water infrastructure, including ICM products, which you will see today. Now, on with our presentation. I'd like to introduce our presenter. Our presenter is Pascal Lang. Pascal is the product manager for Innovyze Integrated Catchment Modeling ICM Solutions, InfoWorks ICM and ICMLive. After initially working at Innovyze as a technical support engineer, he went on to gain valuable experience fulfilling a number of roles in two key water utilities. First as a water supply strategic planner for Scottish Water, and then as an infrastructure planning specialist, and ultimately a wastewater infrastructure modeling manager for Thames Water. He is a key in implementing ICMLive as an operational support tool and embedding this within the process over the past years. Pascal returned to Innovyze in May of 2018. Thank you again for joining us. Would you like to start our discussion, Pascal?
Absolutely. Thank you very much, Caitlin. And thank you for joining us, everyone. Some of the key topics that I'd like to cover today as part of this webinar include models, right? The insights that we can gain from models, and ultimately the consumers of some of those insights that are generated, whether they be internal or external to the company you work within. Then also some of the visualizations and outputs that are available within InfoWorks ICM and some of the tools that are there that can help you improve those visualizations and outputs and make them more easily interpretable by different people within an organization. And then finally, leveraging the connectivity functions within InfoWorks ICM. So talking to some of the maybe external products, third-party products, and getting the most out of your model in those kind of environments. So on to the first discussion then, regarding models, insights, and consumers. So I guess representing a wide range of environments is something that models are becoming more and more key in as we go forward. With the introduction of integrated catchment models, we're now able to represent not only the natural environments as seen on the right there, but also man-made environments and a combination of the two. And then the mechanisms, whether that be groundwater, surface runoff, evaporation, precipitation, and maybe some of the boundary conditions that exist. So thinking about things like coastal tide levels or maybe levels within river reaches that are impacting on the conditions within perhaps a sewer network. And then within the man-made environment, things like the operation of pump stations, for example, maybe sediment buildup within sewers, and some other aspects of those sewer systems. As we move into that environment, we also have more of an appetite to understand the different flooding sources that exist and maybe the interactions within those catchments that actually impact on each other. So in the top left there, we can see maybe some restricted capacity, inflow capacity perhaps for a sewer system when there's heavy downpours or rainfall. In the top right image, some escape, right? Sewer escape from a particular location from a sewer system. In the bottom left, perhaps the overland flow routing that takes place and how that impacts on interactions within a catchment. And then in the bottom right, large-scale inundation across a large swathe of an area. So the solution to trying to identify those flooding causes and understanding those in their fullest is really a single, fully integrated catchment model. And thinking about those environments and thinking about the complexity of some of those aspects, some of those mechanisms, it's not surprising that models are becoming more and more complex. There's a large variability in object types and also structures. So whether it's just a sewer that you're modeling or whether you're going beyond with pumping stations, orifices, sluice gates, perhaps bridge structures across a river, there's a high level of complexity that's now coming into these integrated catchment models. As if that wasn't enough, we're also considering hydrology and hydraulics in the models. So that's both the impact of the surface, so in terms of rainfall landing, what that translates to in terms of runoff, and understanding that hydrology aspect of a model, and a catchment ultimately, and also the hydraulics. So not just what happens off the surface, but also what does that translate to in the sewers? What are the kind of flows, the depths, the velocities that we see? How is our network going to respond to those strains that are placed upon it? Going beyond, we have the ability to model sewers, rivers, overland flow, and some of those components in 1D and also in 2D. And there are numerous inputs to these models. So looking at the right-hand side, those of you familiar with the hydraulic modeling package may recognize that on the western part of this catchment, we have larger subcatchments which look at the hydrology and the runoff in irregular polygons. We don't have a high density of node points. So in the west, perhaps we're looking at trying to understand the hydrology, the runoff from that, into what in this case is of a river reach that runs down the center of the model from the north to the south. In the northeast, we then see far more significant density of manholes, right, of node points, indicative of a highly populated area there and maybe a sewer network that's represented. And then the black polygon that you see is a 2D mesh. So the overland flow routing capability within InfoWorks ICM at such a large scale in terms of being zoomed out, it appears as a black polygon, but in effect, that's an irregular mesh with triangles that represent each small surface area there. As I mentioned, there are numerous inputs that are utilized, and I'm just trying to set the scene here that these models are becoming more and more complex, and trying to understand those mechanisms and interpret what a modeling is telling us is something that's key, but that skill set really sits within modeling teams. So later in the presentation, I'll focus a bit on how we can make this more visually appealing, perhaps, to other people within an organization and modify some of those results outputs. Coming back to the inputs, though, typically when you do a model build, calibration and verification, you would have a flow survey that's carried out, you have rain gauge data, you have GIS data that comes into the model, manhole survey data that comes in, cross-section lines maybe for river reaches, right, cross-section surveys, ground models that are utilized for the 2D modeling, so that they're used for the overland flow routing, building layers to look at the distribution that you might have between pervious and impervious areas in your catchment. Within those impervious areas, maybe a split between road surfaces and roof surfaces. And there are many more inputs that are used just for the creation of a model. Once you have that in place, then really additional value comes from looking at precipitation, depth monitor data, river and groundwater data, telemetry data, to try and utilize that great tool that you've generated in an ongoing way, right? To keep gaining insights from that tool. And to do that, you might take it into a live environment, a near real-time environment, because the insights that that model can provide in terms of how a network might respond to conditions that are current or that are emerging over the next few hours can be key in helping decision-making within a utility or company. So it's able to provide extremely valuable insights over time and on a constant basis, right? So in ICMLive, you might have a model running on an hourly basis indefinitely, right? Every day of the week, every week of the year. But in addition to all of this, there are not just those complexities with a model, there are also varying client expectations that come. Thinking back to when I was working at some of the utilities, there are 4 categories that I came up with here. I'm sure there are many more, but they all have their own sort of approach and their own expectations on what an output might look like. So thinking first about the asset planning function, that's really about the long-term cost benefit for a company, the holistic understanding of a catchment. Typically the asset planners would be office-based and very much report-oriented is what I've put there. They're able to take in a lot of different information related to a single catchment to try and understand all the interactions that might take place there, or most of those interactions, and really dig into the detail of what's happens within a catchment. Another, I guess, client to the modeling activities I've carried out in the past would be developer services, very much interested in the current sort of capacity within a network or the near future capacity in order to understand whether a planned development, whether planned housing is going to have a significant impact on that catchment as a whole. Also office-based, but slightly different in the way they operate in terms of the templated reports being something that's far more common. So the asset planning report, I almost imagine as having all the details specific to that catchment, and they tend to be unique, right, on a catchment by catchment basis. Whereas the developer services reports are mainly about expediency to try and understand, is there capacity? If not, then which one of these tried and tested solutions might be the best one to allow that development to connect, to allow this housing to be built. So there it's much more about a large turnover in terms of number of reports and trying to make sure that development isn't held up ultimately. Another, I guess, client to the modeling services within a company might be the control center. So they're really after the short-term response planning, operational office space, so a lot of phone calls coming in, a lot of communication, and really what's key there for the control center is to get an overview at a glance, right? Get one view at a screen somewhere and understand what's happening in that catchment, what the risk is to the business over the next few hours, and to be able to make large-scale decisions about resource deployment, for example. And then some of the final, I guess, clients that we've had for modeling activities I've carried out within a team have been the field crews, who are really out in the field trying to respond to events that are occurring as fast as possible, and typically don't spend much time within an office, don't sit in front of a computer, but have access to mobile devices. And the modeling team I see is a service provider to all of those different sections of a business and many more. I guess the outputs have to be tailored though, right? They have to be tailored correctly to each one of those functions so that they get the maximum benefit and get the insights that they're after, whether that's short-term, very quick, immediate response actions, or whether that's the long-term planning aspect. So at this point, I really wanted to raise a poll and just ask, who are your main clients or consumers of modeling outputs? So hopefully you should have a poll that appears in just a second. And if you could take a minute just to answer that question and give maybe a bit of an overview on where you think most of the modeling outputs go to within a business. Very good. I'll just give that a few more seconds. Excellent. Thank you very much. So I'll just share the results of that quickly because they are quite interesting. As you might have expected, the asset planning function getting a significant number there, 54% of all the modeling outputs generally going to those. Control center, 13% of the outputs. Field crews, 10% of the outputs. Developer services, 44%, and then 13% for other. So it'd be interesting to know what those other functions are, just to see whether there are some perhaps there that I hadn't considered before. Also nice to see the control center and the field crews having 10 and 13% there, which is great because that's one space where I think models are starting to make a real difference now. That's a direction that they're moving into, from what I've been able to see anyway. So as well as those different clients existing within a company and within the industry, really, there also isn't, in my opinion at least, a single view that is sufficient to accommodate all the requirements from those clients. So you might have, as I discussed earlier, a lot of reports that are generated, lengthy reports that go into the detail of certain catchments. You might have other responses which are short emails where somebody's asked a quick fire question and is just after some insights from the model in terms of what that's telling us for a certain situation. There's also the on-screen visualization, which I believe is very powerful, but that requires the modeler to be in the same location as whoever it is that's viewing that data. Then there are also notifications that get sent out. So the example on the right there is an email alert notification that goes out to potentially someone in the control center or someone in the field, advising them of a certain incident that might be evolving or a certain response that's required. And then finally, dashboards, which are quite powerful in terms of being able to give a quick view on certain data sets, certain insights onto the model as well. So just a second poll on this to see what generally is the format that you would provide or expect to be provided with in terms of the data that's coming out of models. And I've got to admit, on this one, I'm probably less certain on what the answer is going to be than on the previous one. Very good. I'll give that another few seconds as well, and then I'll share those results. So hopefully you should see the results for this poll as well now. I guess aligned with the fact that the asset planning function and the developer services function were the most prominent answer on the previous question. 67% of outputs here either received or generated and sent out in a report form. 9% via email directly, 11% on screen, which is quite a reasonable amount of exposure, I guess, in terms of being able to show the outputs of a model to other people within a business. 9% automated outputs, so exports that are then perhaps read by other systems or alert emails or ingested in some other way, and 4% other. So again, it would be interesting to see what those others are. Thank you very much for that. So now that we've had a quick poll and a quick view on where some of the results are, where some of the outputs go, where some of the insights are generated and sent to, I really wanted to focus on some of the tools that exist within InfoWorks ICM to effectively help out with that generation of reports, that generation of insights on a visual basis, and discuss some of those. So the first ones are the reporting tools, statistical reports, worst case reports, return period analysis, and many more. The statistical reports really helping you with activities like understanding frequency of CSO discharges, for example, under a typical year rainfall series, time series. They're able to give you details on when you have events that have exceeded certain thresholds and how frequently that happens and how you might want to group those. The worst case reports typically used for scenarios, right? If you've got 3 different options that you're testing for as a solution, for example, then running those options with different rainfall events and trying to understand which ones perform the best is something that you might be able to get out of a worst case report from ICM. And then finally, the return period analysis report, which is one that can be used to understand something along the lines of, if I've got these 5 different design storms of different return periods, under which of those return periods do my pipes go into surcharge initially? Okay, what's the lowest return period for which a certain pipe goes into surcharge? And therefore, perhaps what is the capacity utilization that I have throughout the network in different locations? And I'll show some of these in the software in a little while. Another aspect is the themes, layers, and labels, which are key, right? So on the left-hand side and on the right-hand side here, you have exactly the same network that's displayed. On the left with the default themes out the box for InfoWorks ICM, and on the right after being modified with themes, layers, and label lists. So hopefully you can see that the subcatchments are no longer represented on the right-hand side. You can see that the labels are giving us much more of an indication of what the different objects are in this catchment. So the ponds in the north and those green polygons, the yellow lines going from north to south, indicative of where there's a river each located in this case. So there's a river that travels down there. The bridges are the red polygons that you see intersecting that river. Reference to pumping stations, swales within the catchment, the storage tunnel to the south, the treatment plant to the south, and then the 1D urban network to the northeast. So really that, along with the background layer and the theming, giving perhaps much more insight to someone not familiar with hydraulic modeling straight away. The themes are applicable to any object of any type, both for object properties and for results, and multiple themes per object are possible. So what we see on the screen here is a theme that allows you to look at, let's say, the width of a conduit and interpret that as the width of the line that you see on the screen, and then the function of that conduit in terms of the system type, whether it's a combined system, a sanitary system, or a storm system. And in this sort of bottom right-hand side in that screenshot, you can see we've got two pond areas, the green polygons, connected via those teal lines, which are indicative of an overland flow system, a storm system in this case. And then you also see the orange lines that pass across that network, and those orange lines are indicative of a combined system. So just using the themes, you can get much more of an insight in a very short space of time, right? Just at a glance. Layers can be loaded into InfoWorks ICM using map controls of either ArcGIS, ArcEngine, or MapXtreme. ArcGIS and ArcEngine will consume relevant licenses. MapXtreme comes licensed with the software if you download it from our website. They're used to display the layer images or image files that you saw on the background there, and also include the ability to use web mapping services, which don't require a static layer to be stored on the machine or on an accessible location, but instead go online to retrieve mapping files and give you some of the scalability as well that I'll show in the software in just a minute. And then finally, the labels. So you can have both custom or auto labels within the software. The auto labels will populate for every single object of a type they've been activated for, and the custom labels are specific to objects that you click on, right? So if you wanted a custom label for a particular pumping station, you'd be able to populate that however you feel fit. The auto labels will do all pumping stations in the network in a particular configuration, as shown on the right-hand side here, where basically that auto labels grid allows you to populate the label text with any of the fields available for a conduit. So if you wanted to, you could say, I want to populate my conduit auto labels with the upstream node, with the width of that conduit, and with the length of the conduit. Apply that, and it would appear for all the different conduits within your network. And those can be formatted and saved to network objects as well. Going beyond those, what we didn't see on the geoplan earlier is a 3D view. So in version, I believe it was 8.5, the 3D view was enhanced to be far less resource intense than previously, which means you should now have the ability to take networks and put them into the 3D view without encountering some of the memory issues that you might previously have done. The 3D view is particularly powerful in certain situations where you might want to convey outputs to non-engineers. So I found myself in quite a few public meetings, members of the public who maybe have been flooded several times over a short time frame, and then trying to explain to those members of the public where that flooding originated from, what the causes were, is something that's much easier to convey using a 3D view and themes than it would be to try and explain in a report, at least in my experience. And being sat there, showing that on screen is something that's also very positive, that level of engagement. But ideally, you'd have that shown and explained by a modeler who understands exactly what the themes are showing, you know, what the deepness of that blue shows, maybe what the length of the velocity arrows that you might display on a 2D view, what they all show. Again, I'll show some of those in the software in just a bit. Finally, one that's maybe not as widely used, but really powerful is the open as alternate results. So it's powerful for visual comparison, possible to query across multiple result sets. And basically what this allows you to do is to open one simulation result, open a second simulation set of results as an alternative. They will both open in the geoplan, and then it's possible to query the results between them. So I've done this in the past with things like penstock failures, right? So in some situations, if you close a penstock to use it to basically isolate a sewer, for example, then depending on how frequently it's been used and in what state that penstock is, you might not be able to lift it again, for example. In that situation, you're restricting flow on an indefinite basis down that sewer, even though maybe the isolation was only meant to last for a few hours. And in that situation, you might want to understand what is the impact of this penstock being shut and us not being able to lift that again. And in that kind of scenario, it's really powerful to have the open as alternative results because it will show you what the change in flows are upstream of that penstock, downstream of the penstock, and what the impact is overall. And I'll show this again in a second as well. And finally, notifications. So some of you indicated in the poll that you have these generated. If you do, then typically it would be either exported results or it could be directly from ICMLive, for example. Here we've got an example email alert. So on the right-hand side, you can user define a subject line, put a contents into that email, so specify what the text body is for that email, and also embed graphs, which is really powerful, actually. In this particular situation, what we have here is a graph of a location that spills to a CSO, with the blue line indicating modeled results and the red line indicating sensor results. So this is a depth monitor at that CSO location. And as you can see, they track very well up to a point. And this is actually where the simulation started. So we have observed data, we have sensor data up to that point, but beyond this point, everything else in terms of output is generated by ICMLive based on forecast rainfall conditions. And in this case, I believe the trigger for the alert was 1.3 meters. So once you go above that depth, there's a response that's initiated by the control center. And this is an example of one of those email alerts effectively saying we have an onset time of 11:01 GMT where we've got this particular alert that's been triggered, initiate a response protocol for that. So what I want to do now is basically go through a few of those aspects in a model in InfoWorks ICM and just talk through them basically. So I've just opened 9.5, which has just been released. And what we have here is that same model network that we saw earlier. So the river's passing, in this case, from west to south. Bridge structures just here where we see the roads crossing. And we also have down here a pumping station that lifts flows to a tunnel, a storage tunnel that's under the river here. And the rest of the flows would typically pass down to the sewage treatment works along this line. So what's happening here is basically you run a rainfall event, and under certain conditions, the storage tunnel will be utilized. So this pump will come into action. It will discharge via this link, and the flows will be stored until there's capacity at the sewage treatment works again. Once that capacity exists, then this tunnel will be emptied gradually, and the sewage treatment works will treat those flows. But what I wanted to highlight here is a statistical report, which basically just requires a location. So what I've done is taken this link that's highlighted, put that into the statistical report, and said for a threshold of 1 liter a second, because usually that link would be completely dry, trigger an event as part of this statistical report. And all we do then is go to results, statistical reports, drag in the simulation that's been utilized here, drag in that report, and then click produce report. And that will give us a list of all the different occurrences where that threshold was breached. So we've got one event here, which started at 10 o'clock on the 3rd of October 2017, lasted for 20 minutes, gave us a peak flow of 3.9 meters cubed a second, and a spill volume of 1,726 meters cubed. And then we had a second event from 11:25, which lasted 275 minutes, with a peak flow of 4.6 meters cubed a second, and gave us a spill volume of 50,460 meters cubed. Now, if we look back at the results for that particular link on the simulation, we can see that actually we have one discharge here from the pump. It switched on again at this stage, switched on again there, switched on for a little bit longer here, and then we had a prolonged period of discharge. So why are we only seeing 2 occurrences of this in the statistical report? Well, one of the things that we can define is combine events where gap is less than a certain period. So in this case, 1 hour, which means that if we look back at this, we've got the 10 o'clock onset time here. That spill lasts. We've then got a dry period. Then when this next spill occurs, we never have a 1 hour dry period between the end of one of these spills and the next one. So this is all treated as a single combined event in that case. And that's just an example of the statistical templates that we have within InfoWorks ICM. I guess another thing that we talked about was just the visual aspect, right? So here is that network that I showed in the slide earlier in its default form, a default display. I've got a predefined theme that I can drag on, which will remove all of the subcatchments, change the coloring slightly, and that already gives us more clarity on the structure of this network. Then the ability to have predefined layers that we bring into the background, which show us a bit more like a golf course up here, for example, sports fields, some pervious areas, some shrub area. So a lot more that we can gain from having that background mapping. And then ultimately, the ability to also put long labels on. These have all been stored previously, but they can be generated by simply clicking on the label tool and then on the link and populating the necessary information there. And this is how we get to that view that tells us we've got ponds and these green areas, these green polygons. We've got the river reach passing down to the south where we've got yellow bank lines. We've got bridges that are crossing, and zooming in, we can see they match up with the actual bridges from the background mapping. We've got pumping stations just here, swales in this part of the network, and then storage tunnel down the south, the treatment plant, and the urban 1D network to the northeast. One of the ways that also I think I've managed to embed the use of ICMLive and real-time modeling as a whole within a previous utility actually, is by doing something as simple as taking rainfall visualization and displaying that relative to the network model, right? So in this case, what we're looking at is actually a radar grid, part of the NextRad grid, which is available in the US, overlaid onto that catchment, and just the ability to see how rainfall intensities pass across and what impact they have made a real difference to some of the previous utilities that I've worked in, because these visualization tools actually didn't exist. They had access to rainfall data, but didn't have the ability to visualize it in the same way. And as I play through the simulation, what you'll see in a second is we start to see intensities passing across that network. The yellow and the light green are the low intensities. The orange is the highest intensity threshold on this theme, which actually is over 120 millimeters per hour in terms of intensity. In addition to that, if you noticed, we have these blue circles that appear. What I'll do is I'll just take on the maximum results here. We can see we had really high intensity almost across the entire area. And one nice thing about this, I think, is that it really shows that the area for the 2D modeling, where we have the triangles in here, was deliberately chosen, and well chosen in this case, to represent the overland flow from the highest affected areas for flooding, right? We can see all these blue circles where we have sewer escapes happening as part of this really intense event. But actually, if we go outside the 2D zone and look, we only have very isolated pockets of flooding onto the surface. So let's look at that in a bit more detail. Here we have that same simulation, and really what I'm trying to show here are some of the ways that you can display the 2D flows, right? The mesh flows that exist within ICM in this case. We've got some ponding already, so where you see this deep blue, we have high depths on the surface. Where you see the lighter blue, we've got lower depths. And as we approach the 1 p.m. mark, we get that really intense rainfall, and then we start to see the response on the surface. And if I pause that again and go to the maximum results, then what we see here are the accumulations of that depth, maybe around the baseball pitch at the top here, some in this pervious area. And this is really powerful for trying to convey a message to maybe people that are not within modeling teams, right? Try and give the crucial information from the models and insights, such as in this case, we see that we've got flow that's giving us a depth in this area here. We've got a depth that's coming up here. They're accumulating in a single, they're joining basically in a single point. And that's where we start to see these orange arrows, right? So the blue is giving us the depth, and the orange arrows are giving us velocities above a certain threshold. So once the two flows join here, they're sufficient to induce that threshold to go above what's been set in the themes. Other insights that you might gather from this would be that typically the flows follow the roads, which are below curb height, as you might expect. But then in some locations, there's more risk, right, to property and to life potentially, because the flows are so genuinely high that they pass across the more pervious areas between the buildings in this case, and then end up accumulating down by these larger buildings before we then see this deeper red, right, this much darker color on the velocity arrows for the flow, indicating that we've got really high velocities here. And if I just graph any one of those elements and look at the speed, we can see that it gets above 4 meters a second. Really significant speeds there and quite dangerous to life if you're stood in the path of that flow. Ultimately, that goes down to the river boundary and then enters the river reach in this case and is then conveyed further throughout the system. Going beyond that, going beyond the plan view, we can take those insights and actually we can make this even more impressive in terms of a visual aspect and easier to follow by taking all this into a 3D view. And as I said, we've made some improvements to the 3D view that should hopefully mean that you can load a lot faster and load bigger networks as well. So in the distance, we can see the 1D network that extends beyond the mesh, and we can see the layers here that have been overlaid onto that mesh as well. So if I fast forward to approximately 1 o'clock, we can replay through the simulation in the same way. And even at this scale, in terms of the size of the network, we're able to see the impact and see the same themes that we might have applied on that 2D plan earlier. Note we also have a representation of the bridges with the openings in between as well. You can just about see that through there. So yeah, explaining to people or maybe those that aren't modelers and showing them this kind of output from a hydraulic model really helps them to relate and often actually gives really informative and useful feedback as well in terms of actually that we didn't see the flows going down that way, we saw them going down this road or the depths reached this point. So it really helps to take that anecdotal evidence and help build that into your model calibration as well. And I guess the final thing that I showed on the slides was the ability to overlay results and look at the difference between them, right? So as part of that model, we've got these 3 pumps up at the top of the network, which are just here. And they go down 2 rising mains. So there's one rising main there, and there's another one just here. So what I've done in one of these scenarios, I've basically disabled this pump from functioning, the one on the right, right? And when I disable that pump on the right from functioning, the rising main, the northern one of these 2 rising mains is completely unutilized, okay? It's not utilized by any flow because it's only served by that one pump, which is this one here. And if I open those results, I open the second one via right-click, open as alternate results for comparison. You'll note that the header changes, so you've got both simulations, the first one plus the second one. And what we can do now is we can apply a theme set. And the reason I had to drag it on twice there is because the first time I drag that theme set on, it applies the themes to the model network. The second time I drag it on, it provides the calculation outputs from the comparison. So just to give you a quick view of what this is doing, I've put an expression in for flow change as an SQL expression, which is really powerful, and ICM allows you to do a lot of different things, complicated things as well. But in this case, it's very simple. I've opened up those 2 results, and all I've done is I've said sim max downstream flow minus sim2 max downstream flow is the output that I want to theme on. Okay, so this is just looking at the difference in flow, maximum flow between the 2 simulations, and it's providing that as an output, and then I can theme on that output. So what this is telling us that if it's less than minus 0.01, so less than 10 liters a second, it'll be red. If it's greater than 10 liters a second, it'll be green. And if it's between those 2 values, so between minus 10 and plus 10 liters a second, it'll be brown. What this is basically doing is saying, okay, if I've got a flow increase between those scenarios of more than 10 liters a second, color the link green. And if I've got a flow decrease of more than 10 liters a second between those 2 scenarios, then color the link red. And as you might expect, the area just upstream of this pumping station has lots of red conduits, right? Showing us that effectively the discharge capacity from this pumping station as a whole is reduced. We've got more flow backing up. We've got a reduction in those flow rates. Whereas in the rising mains, one is reduced and one is increased. And these are head discharge related pumps. So basically these 2 are providing a higher flow rate for the higher upstream head than they would have been with the 3rd pump operational, which is why we see this green line. And zooming a bit further down, we can see that there are some contributing links to the same line that the rising main is on that was originally served by the pump that's now been disabled, which have higher flow rates, right? So these contributing lines here now have higher flow rates because there's less of a downstream head to reduce that flow rate. So it gives us quite a quick overview on the impact that maybe the failure of one asset or the closure of one asset has overall on network performance and network activity. And I guess the final section that I wanted to talk about was related to leveraging connectivity functions in ICM. So one thing that I found was that actually working within utility and within different teams and people that perform different functions, there might be different ways of looking at things or expressing certain concepts. So I have to admit that during my my modeling career, I've always thought of locations in models in terms of either coordinates or a model ID, maybe an asset ID if lucky, right? If there's an asset ID for every object that is there for a utility, then maybe use that, or for an asset register. And typically those that take customer calls, customer contacts, work out in the field would locate based on postcodes or street names and numbers, right? So there's a difference there in terms of how things are approached. And I just want to talk a little bit about a real life example that happened maybe about a year ago or so now. It was the weekend and there was a sewer collapse which occurred. So what happened was that technicians were sent out to that location, but ultimately they didn't know what equipment to take or what overpumping to take in terms of pump sizing to be able to accommodate some of the flows that would be arriving at that collapse location. So the modeling team was contacted by the control center and asked, what flows are there at location X, right? This location where the guys are going to, what flows are we expecting there over the next 6 hours, let's say, so that we can make sure that the sizing of the pumps that are going to be sent there is appropriate for the job that they're going to be having to do. We already had live simulations, right? Those were already happening on an hourly basis with a 6-hour forecast. So in this situation, all that was really required was for the live model to be looked at, the graph tool to be selected, and a couple of clicks, right? One click on the link and then one click to select the flow as the result that we're interested in, and then send that back to the control center, right? That could have been done in probably less than a minute within getting that call. But what actually happened was that I was told the location. I was given either a street name or a postcode. I can't remember exactly which. And I then had to open the GIS package, right? I had to get onto the GIS portal, which took quite a while to load because there's a lot of assets that are stored in there. I then had to look up the postcode or street name from that portal. I then had to locate the asset. In this case, the collapse happened in very close proximity to a railway, right? So that was the kind of bit of detail that they gave me that allowed me to locate the location, right? And then from that, I had to find the asset, take the coordinates of that asset in the GIS package, and then go back to the model, look for those coordinates, and then find the sewer link in the model, and then do my graph tool, and then select the flow, and then send that graph back. But ultimately, the steps 5 through 9 that I've highlighted there are ones that took the majority of time in this whole workflow, right? I'd say probably about 60 to 70% of the time it took, which was about half an hour to get that information back, came from steps 5 to 9 there. And a delay of 15 to 20 minutes in a situation like this could be the difference between a property flooding or not flooding. In this case, it was lucky that there was no rainfall at the time, so the risk was reduced. But if it had been raining, it could have been much more significant, the impact, right? So really, what I found out since then, since coming back to Innovyze, is that there's already functionality that will help us to vastly speed up that response and identification of assets. So I guess the first thing is that the web mapping services are listed on this this blog post that's been hosted. We also have a GIS find tool. So if you're lucky enough to have GIS layers that you've got in the background that you can use and search on using ICM, you can select the layer, then the field that you're trying to search on, and finally an expression, right? So the name of the object that you're looking for, the name of the street, maybe if you've got a field for that. But we also have something called the Google or Bing Maps find in the find tool, which are the key ones that I wasn't aware of previously. So I'll show those in just a second. And finally, we've also got some connectivity functions in terms of view online, where you can go straight to a location in Google Maps, Street View, Microsoft Bing, or OpenStreetMap, and view that location in those URLs effectively, right? They're automatically generated and populated in a browser from within ICM. So before I go on to that, just coming back to this one here, the Google and Bing Maps find requires an API key to be able to utilize those functions. So as a company, you'd already require, or an organization, you'd already have to have a Google or Bing Maps find API key. I wasn't aware of these until well, when I discovered this functionality, really, I guess. So I'm just curious about how many of you know whether your organization already has those APIs. So I'll do a quick poll on that. This is just for my interest, I guess, to a certain degree, because it's certainly something that I was unaware of for a long time, that there were API keys that you could use to access Google Maps or Bing Maps directly and get outputs from that. I'll give that another 10 seconds or so. Excellent. Thank you, everyone. So just to show those results, I'm glad I wasn't the only one that wasn't sure originally. So 22% of you have Google Maps API keys, as far as you're aware. 8% have Bing Maps API keys, and 70% are unsure. If you're using ICM or ICMLive in this kind of operational support sense, or even if you're not, right, because you might be given a flooding location to investigate for a certain observed rainfall event and want to check whether the model replicates that flooding, then it might be worth seeing whether you do have those API keys available within the company. They usually come with a certain number of requests a year that you can make, which are in the thousands. So unlikely to hit that limit unless you're doing anything particularly resource intense in that respect. But basically what it allows you to do, going into the operator client for ICMLive here, what it allows you to do is to go to the find tool at the top. And let's say I was in that same situation. Okay, let's say that I was told, hey, we're at a junction between, I know that there happens to be a Sizewell Street and an urban road in this catchment. Can you tell me whether we should be expecting any issues there? Well, then you go to the find tool and you select either one of these, right, depending on the ones that you have an API key for. And it's something as simple as typing in Sizewell Street and urban road, then hitting find. That's then trying to get a response from Bing Maps. And once you get that response, it gives you what it's found, right? Sizewell Road, an urban road, less than, then a postcode in the United Kingdom. Double click that, and it will immediately highlight that location in the geoplan. It will put a cursor there. And if a sewer collapse had occurred here, it's good that it's as accurate as it is, because you know the flows that you might give back to the team, depending on whether you expect the collapse to be on this line or this line, could be completely different. And from this location, something else that I wasn't aware of until fairly recently is that you can right-click, view online, and go straight to Google Maps. And that will build the relevant URL and take you to that exact location, which is what it's done here. Alternatively, in the operator client, the other thing you can do is right-click, view online, and go straight to Google Street View. And in this case, that would give me an immediate street view of that junction between the two roads. Sizewell Road there, Urban Road there. And before the team even gets there, you could do something along the lines of saying, hey, can I see a manhole anywhere that I can tell them about? And there's one right there, right? So you could gain all that information in probably less than a minute, as opposed to the 15 to 20 minutes response time that I had previously. And actually, with the number of requests, this would have made a difference to me in previous functions where I dealt with a whole host of these kind of requests on almost a daily basis, or at least a weekly basis. So I think that concludes really the webinar in terms of the topics that I wanted to cover and talk about and sort of show in the software as well. I can see one question, which is, can you use SQL in the labels? I have a suspicion that you might need to use the SQL to create a result in a similar way to the simulation comparison that I did, to be able to reference that in a label. But what I'll do is I'll double check that right after this webinar, and then send a response out to the person that asked that question. And there's also one more question that's been raised about how can we gain more trust with operational teams. And I think for that one, from my experience, what I've tried to do is just, as I said previously, look at the modeling team as a service provider for the rest of the business, right? Providing a service and output that can then be utilized by other parts as they wish. So in the past, I've used ICMLive to start generating some of the notifications when people have raised particular problems, start generating some of those alert emails without necessarily following up on them immediately, but just giving them that flow of information, those modeling outputs. And once you've had 2 or 3 events where they've proven to be correct, that starts to generate trust. And by the time I left one of the utilities, it was really encouraging to see that if we had a question about something that was maybe happening in the sewers, right? We had maybe a monitor that was tracking really well against the model for a prolonged period of time, and then suddenly went out of that calibration space. And we asked some of the operational teams about that, because they were relying on the models for certain actions they were carrying out and getting insights from those models. Actually, it started becoming a two-way thing, right? So self-perpetual, really, because those ops guys would then go out of their way to try and get additional information on that particular length of sewer, on that sensor, and then feed that back to the modeling team in the knowledge that that in turn would improve the model quality and give them better information to make decisions off, right? So yeah, that was really encouraging, and that's a great question. So other than that, I don't think there are any. So just thank you for attending. Thank you for the questions, the feedback, and yeah, if you have anything further, don't hesitate to get in touch. My details are on screen now. Thank you.